Greetings everyone. I am honored to present my research work in the 4th International Conference on Recent Trends in Computer Science and Electronics. My paper ID is 233 and the title is Spectral Amplitude Coding Optical CDMA Performance Analysis on Free Space Optical Channel. So let's first see the presentation skeleton. It consists of introduction, system model, performance analysis, results, conclusion, acknowledgement, and references. Let's start with the. In the introduction, let me first give you a basic understanding of next generation networks. What are NGNs and what is their key issue? Next generation network is a kind of network in which you will be able to um, control all different types of networks all together on a single platform. That means there will be common type of protocols or communication system between all these networks. Currently, um, the different type of networks are public switch telephone network, um, that is PSTN. Uh, we have internet and data network, we have cable networks, we have wireless and mobile networks. So they actually are using different types of set of these protocols are going to converge all together into a network known as next generation network. And by doing that, we won't have different set of protocols, we will have same set of protocols. So the problem the problem is, in the core side we already have passive optical networks, we have optical fiber, and we are using time division multiplexing or wavelength division multiplexing. In the access network we are using cable or DSL, and in home we are, or in an office or whatever building it is, we are using LANs, wireless LANs or DSS. So the core has 100 terabit per second data rate, and due to the same cable and DSL systems we have few megabit per seconds in the access network, and at the home we have a wireless LAN, and the requirement at the user end is large because basically we want to control every type of device. We are using internet and high definition internet on different devices at a time, so the requirement is not fulfilled. And another thing is, all these three are using different set of protocols. You can see by the colors they are using different set of, these colors are representing that these are using different set of protocols. So the issue is, we have bottleneck problem in the access network. The proposed solution is to implement optical fiber in the access network, and optical fiber that can use the atmosphere is known as free space optical channel, FSO. So core is already giving you 100 terabit per second. It is, and in the core we are going to use optical CDMA. In the access network, by using free space optical based on CDMA, the data rate will be increased to 100 megabit per second. So at the user end, on the last mile, the requirement will be fulfilled and the data rate is going to increase. So the bottleneck issue will be resolved. As you can see by these dotted lines, the bottleneck issue will be resolved. And because all these three are going to be having the same set of protocols, so there will be in a single color, you can see here. So in this paper we investigate the performance of spectral amplitude coding optical CDMA technique based on free space optical channel. SEC-OCDMA is one of the most popular multiplexing techniques, and FSO is gaining popularity and is very useful, especially in point-to-point communication. In SEC-OCDMA, we are using Walsh Hadamard code as signature code, and the encoder and decoder structures are based on optical filters known as fiber Bragg gratings. And these fiber Bragg gratings are basically very intelligent. A single fiber is grated according to the required wavelength, and that will at the output you are going to get exactly the wavelength that is required. That is actually needed. Focus of this particular work is on the performance of analysis of free space optical based systems for subtropical regions. That basically means Pakistan, India, and such regions having subtropical atmosphere. This work is focused on it. The free space optical channel. What is it? It is basically an alternative to optical fiber cable or RF and microwave systems. Free space optics has proved to be the ideal choice for the access technology of next generation network. It can deliver an effective line of sight, wireless, and high bandwidth communication between two places. Free space optical communication is based on optical communication with only difference that here the light signal which carries the information is not confined into physical channel such as an optical fiber. In free space optical communication, the optical signal is transmitted into free space, air, or vacuum space. So basically, you won't have to dig or bury the cables. You won't need anybody's permission. You won't need any licensing. You just need to install a transmitter and receiver circuitry, and that's it. You in free space optical communication, your system will go license free. You won't Nobody will be able to eavesdrop, because these laser signals that we are going to transmit, they cannot be uh, stealth, or you cannot copy them or do any such thing. The only issue in free space optical channel is weather condition. So according to the weather condition, we need to set a value of attenuation and see and analyze what will be the response of the system, how how much attenuation it can withstand, up to which distance it can withstand, and what is the minimum distance that can give you a successful transmission even in the in harsh weathers. Harsh weathers basically means the weather can be rainy, foggy, smoggy, or any such thing can be happen to the weather. So so let's see how FSO works. um, First of all, network traffic converted into pulses of invisible light representing ones and zeros. When your signal is converted into ones and zeros, then transmitter projects the carefully aimed light pulses into the air. Then a receiver at the other end of the link collects the light using lenses and mirrors, and finally received signal converts back into fiber or copper and connected to the network. And the reverse direction data transported the same way. That basically means free space optics is actually a full duplex system. So basically anything that can be done in fiber is equally applicable in free space optics. Now, spectral amplitude coding, optical CDMA. SEC is widely used as it is considered an effective arrangement to eliminate dominant noise called multiple access interference. SEC is a technique of optical CDMA to encode and decode data bits by utilizing spectral components of the broadband source. SEC OCDMA has been in focus of many researchers for many years. Due to its features and usefulness, it is being used in many ways, especially in access and core networks. So this is basically the system model of SEC OCDMA FSO channel, and here you can see that n number of inputs can be given. Similarly, n number of outputs can be given. These two systems, input and output, that's transmitter and receiver, is actually connected using an FSO channel. In this system, we have used 3 users. So every user comprises of a pseudo random bit sequence generator that is connected with non-returned zero pulse generator that is going to convert the ones and zeros into pulses. White light source is going to give you your light signal. These two are connected with Mach-Zehnder modulator. After modulator, it is connected with fiber bragg rating 1 and 2. FPGs are going to select the required wavelengths for user 1, similarly 2 and 3. All these 3 inputs are connected with power combiner. Then they are transmitted on a free space optical channel. At the receiver, again it is connected with the power combiner, and then it is given to power splitter. Here in the splitter, it is given to fiber bragg rating 5, 6 and 7 and 8. So the wavelengths will be divided here, and then they are connected with PIN photodiode. PIN photodiode outputs are connected with electrical subtractor, and finally the signal will be passed through a low pass Bessel filter. So the transmitter consists of this part, the receiver consists of this part, and the transmitter consists of this part. So this actually gives us a basic system model for our. In the performance analysis, here eye diagram of 2 cases is shown. What we have done is that we have taken different ranges like 200 meter, 500, 1 kilometer, 2 kilometer, 5 kilometer. And in the attenuation, we have taken 100 dB kilometer. And here on the slide, we have shown 100 and 300 dB. But basically, we have taken 100, then 150, 200, 250, and then 300. As you can see here, that on 100 dB attenuation, and when the range is 200, when signal is transmitted, we are getting a perfect eye diagram. So that basically means the signal transmission is successful. Similarly, again on 100 dB attenuation, distance is increased up to 1 kilometer, and the signal transmission is perfectly done, correctly done, and the eye diagram, you can see it's a perfect eye diagram. As soon as the distance is increased from 1 to 2 kilometer, the signal suddenly degrades, and it shows that there is no successful transmission of the signal on 100 dB attenuation when the distance is 2 kilometer. Similarly, the worst condition according to subtropical region, we have taken 300 dB kilometer attenuation, and here you can see that only on 200 meter distance your eye diagram is shown perfectly correctly, and as soon as we are increasing the distance to 500 meter, the signal again degrades, and it remains degraded, and there's no transmission of the data. So it basically shows that in the worst condition, 200 meter distance can give you a perfect transmission of the signal. So in this performance analysis, we have learned that even in the highest value of attenuation, we are getting signal perfect transmission in the range of 200 meters. That is basically the requirement of last mile communication. So the results are this system can withstand attenuation of 100 dB till 1 kilometer. Attenuation is increased to 150 dB per kilometer. The signal starts to degrade from 1 to 5 kilometer, and successful transmission of data is possible till 500 range. Increase the attenuation to 200 dB per kilometer to 250 dB per kilometer. Successful reception of data till 500 meter range. Once the attenuation is made 300 dB per kilometer, the signal drops and possible signal transmission is only till 200 meter range. Bit error rate value under all successful transmission is around 10 raised to power minus 21. However, a sharp degradation in bit error rate value is noticed once the attenuation value and distance is increased. So the conclusion is very simple and straightforward. The performance of free space optical channel heavily depends on the attenuation and experiences sudden drop once the link distance is increased. This work is supported by Mehran University of Engineering and Technology, Pakistan. Here are the references. Thank you.